Hello everyone. Today we're exploring a more advanced math concept, calculating the gamma function using the Lanczos approximation in JavaScript. The gamma function is a continuous extension of the factorial function, used in probability theory, complex analysis, and more. Lanczos method provides a fast and accurate way to compute it numerically. Let's look at how to implement this in an elegant algorithm in JavaScript. The gamma function generalizes the factorial. So while 5 factorial is 120, gamma 5 equals to 4 factorial, which is 24. But here's the catch. The gamma function works for non-integers too, like 3.5 or pi. That's where the Lanczos approximation comes in. Gives us an accurate way to compute gamma n, especially when standard factorials fall short. This function begins with a list of coefficients specific to the Lanczos approximation. The heart of the logic is this. If num is less than 0.5, we reflect it using a clever trigonometric identity. Otherwise, we loop through the coefficients to build an approximation for the gamma value. At the end, we apply a final formula using exponential and power operations that return the results with precision. Let's walk through it. Step 1 is setting up the constants that define the shape of the approximation. If num is less than 0.5, we flip it using a reflection formula that avoids division issues. Next, we subtract 1 from the input to align with the algorithm's format. Then, we loop through and accumulate weighted items. Finally, we will multiply it all together in one big return formula, giving us an accurate approximation for gamma n. When we plug 5, we get roughly 24, just like 4 factorial. For 6, we get approximately 120, matching 5 factorial. But more importantly, for 0.5, the gamma function gives us around 1.77, something factorials cannot handle. This shows the true power of the Lanczos method, accuracy, and generalization for all positive real numbers. The gamma function is no niche tool. It is everywhere. You'll see it in probability, distributions, especially in machine learning and data science. It plays a key role in cryptographic math, and it's embedded in physics simulations, signal processing, and much more. So knowing how to calculate it efficiently is a great tool in your developer toolkit. To sum up, we've used JavaScript to implement the Lanczos approximation for gamma function. It works for integers, fractions, and much more, handling everything gracefully. It is fast, elegant, and practical for real-world applications. Thanks for tuning in. If you found this useful, be sure to check out the other math breakdowns. We've got plenty more coming your way. Thank you for watching. If you enjoyed this tutorial, please make sure to like, share, and subscribe for more JavaScript tutorials. I'll see you in the next one.